So there was a question on how to do this problem or how to check and see if it's correct in the book, because there's sometimes errors. So this is part of nomenclature, and again you want to find your longest chain, and that's your parent chain. So we're going to number the longest chain, and it kind of looks like this, but let's just confirm that this is the longest. 1, 2, 3, 4. That's not very long. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, and 8. So either way, this is 8. I'm just going to go straight line, make it simple for ourselves. And 8, so I'm going to go ahead and say it's all single bonded, because I can tell by the hydrogens. If there's 3 hydrogens around here, the 4th bond's to the carbon. This has 1 bond here, and 1 bond here, and another one here. So that's going to be, and then another one to this carbon. So if this was stretched out, this little hydrogen would actually be kind of like out here. This hydrogen would be moved, and that would be 4. So 1, 2, 3, if that was down here, and 4 to that carbon. So that one's all fine. So this is how I can tell it's single chains, is by just counting how many it's bonded to. Like this one here is 1, 2 to that one, 3 to this one, and 4 to that carbon. So all single. So it's going to be an ane. And it's going to be 8 of them, so it's going to be octane. And then I have groups, and the reason I numbered this way down is because the bulkier chain gets the credit. It gets numbered first. The less bulky get numbered last. So you could have numbered 1, 2, 3, 4, 5, 6, 7, 8, and it might be in the book that way, and maybe that's why it's a problem, because sometimes they do that. They just kind of did them really quick, I guess. So now I'm going to go ahead and name this one. I have an ethyl group here on carbon 2, and methyl on carbon 5, and another methyl on carbon 7. And so I'm going to number this one 2-ethyl. And it's going to be di. There's 2 methyls, so it's going to be 5, 7. 5 and 7. Oh, I guess, sorry, yeah, a hyphen. And that's going to be dimethyl, because there's 2 methyl groups. And then our octane. And the octane is single bonded. There's no double bond, so I don't have to number it. It's just octane. So 2-ethyl 5,7-dimethyl octane. And sometimes they do the numbers up front. They'll go 2, 5, 7 ethyl dimethyl, which I am staying away from that. I like this. It's more organized. Sometimes it might have little parentheses. That's fine too. There's a couple of little tricky things. But the next question was on number 7. And number 7 is, why is the name of 3-butyl pentane incorrect? So we need to draw it. You work backwards. Go this way. I have an ane, single bonded carbons. Then I have pent. That means 5 single bonded carbons. 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay, single bonds. And then I have a butyl on number 3 carbon. So I'm going to make my own chain here, and I'm going to say that this is, I'm going to start from the beginning, left to right. 2, 3, 4, 5. And then I'm going to put on the 3rd carbon a butyl. So up or down doesn't matter. But is going to be 4. So I'm going to go 1, 2, 3, 4, another 4 chain. Okay, that's going to be butyl. This is my butyl. And then this is how they're naming it, and this is my pentane. And this is on the 3rd carbon, so 3-butyl. So it looks like that. So why is this name incorrect? Well, if you count the parent chains, let's just double check and count parent chain. So I could go 1, 2, 3, 4, 5, how I created it, or I can go 1, 2, 3, 4, 5, 6, 7. Well, guess which one's my longest chain? This one is. Okay, so the new name for this one, because it says what's the correct name for it, I'm going to go down here. I'm going to go 1, 2, 3, 4, 5, 6, 7, longest chain. And then I'm going to call this one heptane. And And then this little group hanging off, I have a 2-carbon group hanging off of number 3. So these don't count. So I'm going to have 3, and this little 2-carbon group is an ethyl group. So I have 3-ethylheptane. That's its real name. So that's the second part of the question. Okay, so they just numbered the wrong carb chain. The longest chain wins. Or the one with the double or triple bond wins. Last question on number 10. First of all, right off the bat, these are all cyclo. So we're going to name them cyclos. So you're going to be using cyclo. Okay, because they're all cyclic. These are cyclic. They come all the way around. Every point is a carbon. So every little, let's see, we'll do it in orange. Every point is a carbon. So there's a carbon here, 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 and here. So if I look at my bonding, I have 1, 2, and that means that leaves 2 more bonds. So this is going to have actually 2 hydrogens sticking out of it. But if you look at cyclic, same thing with this one, if you start doing that, it's super messy. So they don't write in the H's, you just assume that they're there. Okay, but this one, it has 1, 2, 3, and then 1 hydrogen hanging off. So you can see it gets kind of bulky and messy. So that the H's are there, but when you don't see them, it's just assumed that we understand is a cyclic, that has carbon has 4 bonds. So it'll have to be counted. So if I wanted to draw this out, like kind of like a structural formula, I would start out with like the CH, put it in CH3 group hanging off, and then I go CH2, 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 CH2. So we understand that. That's something you'll have to learn as you practice. But as far as nomenclature for naming this one, if I count the sides of my shape, depending on what it is, I will know how many carbons are in it. So 1, 2, 3, 4, are not sides, the corners. 1, 2, 3, 4, 5 carbons. And because this group is hanging off of here, I'm going to start here as my 1, 2, 3, 4, 5. So this one's going to be a 5 single bonded. So it's going to be pentane, but it's not just a plain pentane, it's a cyclopentane. And it has 1, on carbon 1, it has a methyl group. So 1 methyl, cyclopentane. Here, I'm going to count all the carbons around in the, because a closed shape, the cyclo, overruns any other chains hanging out here, okay? So always start with the cyclo. The biggest chain is right here, the ethyl one. So 1, 2, 3, 4, 5, 6. This is hexane. It's a cyclohexane. And then I have on number 1, I have an ethyl. And I have 2 methyls, so I have a dimethyl, and it's on 2, 5 dimethyl cyclohexane. And you don't need a number for a cyclo, unless there's like cyclos, which can happen, cyclo on a cyclo on a cyclo, but then, yeah, we start using common names for those, because they get really, really, really long. And these are teeny, tiny little molecules. This is small for organics. So you could have all these guys could actually be linked together to create a whole new organic molecule. That's why we're so complex. Compared to something like table salt, NaCl, we have all this going on in us as dynamic humans and living organisms. So they are complicated and they start packing together. Okay, so this one I see I have an ethyl group here and an ethyl group here. And it doesn't really matter which one I start on because they're equal sides away. 1 carbon, 2, 3. Doesn't matter, 1, 2, 3. It doesn't really matter, but I do need to start at one of these. So I'm just going to start at the top. 1, 2, 3, 4. There's 4. So this is butane, and it's cyclobutane. And I have 2 ethyl groups, 1, 3, and it's diethyl. Okay, so on 1 and 3, I have an ethyl group, so that means there's 2 of them, diethyl, and then cyclobutane. Hopefully that helped.